Hello, in this class we'll be looking at the classes of carbohydrates. Meanwhile, in our previous classes we have drawn the structure of glucose, which is a monomer of carbohydrates. In fact, a type of monosaccharide sugar. Meanwhile, in the class of carbohydrates we have the monosaccharide. We have the monosaccharide. We have the disaccharides, alright, and then we have the polysaccharides. Now, this concept is what we're looking at today. So let's pick up the first one, monosaccharide. What actually is monosaccharides? Monosaccharides are simple monomers of sugar, or one unit sugar, which cannot be broken down into simpler sugar. I take it again. Monosaccharide are simple unit of sugar, which cannot be broken down into smaller units. And this monosaccharide example is the glucose, the fructose, the galactose. So any of those are monosaccharide. Meanwhile, the monosaccharide sugar ranges their carbon atom from carbon 3 to carbon 4. So we're looking at the monosaccharide that comes from carbon 3 to carbon 6, not carbon 4. Now, carbon 3 is known as the triose. And triose, a good example is glycerose. And then the carbon 4 is known as tetrose. A good example is utrose. Then carbon 5 is known as pentose. A good example is the ribose sugar. Now I'm going to stop here again and before I continue. Because the ribose sugar is what forms your DNA. The ribose sugar is what forms the DNA. Now, we have deoxyribonucleic acid and ribonucleic acid, RNA, DNA, respectively. Now we have the C6, which is the exose. Now, this exose is either the glucose or the galactose or the fructose, which is the most common type of monosaccharide. Well, monosaccharide can be hydrolyzed, or it can undergo, not monosaccharide, anyway, disaccharide can be hydrolyzed. These examples are for monosaccharide. Hydrolysis, I mean by the addition of water and some catalysts like maybe HCl, dilute HCl, and dilute H2SO4. That is for disaccharide. We can now hydrolyze whether it's maltose to form glucose and glucose. When we get there, we'll talk about that. But meanwhile, let's talk about the disaccharide now. So, let's talk about the disaccharide. Now, what's disaccharide? Disaccharide is formed by the combination of two sugar units. I take it again. Disaccharide is formed by the combination of two sugar units. Now, if you have glucose plus glucose, you are going to have maltose. Maltose and water. If you have glucose plus, if you want to form lactose, which is known as milk sugar, this one is called malt sugar. If you want to form the milk sugar, milk is drinkable, while gala is eatable. Galactose. There is a sausage in Nigeria West Africa they call gala. So milk, drinkable, gala, eatable. So galatos. And then we have lactose plus water. Remember, it is called milk sugar. That is the sugar found inside the milk. Now we have another one, glucose plus fructose, which will give us sucrose plus water, H2O. This is called cane or beet sugar. Now, a question might come up in the hall in your exams, and they say, maltose contains which and which unit of sugar? Glucose, and glucose is the answer. Lactose contains which and which unit of sugar? Glucose, galactose. Then sucrose contains which and which unit of sugar? Glucose and fructose. Let's see how to draw the structure of glucose and the structure of fructose. Let's see, what we're going to be doing with that structure is that we use two structures of glucose to form maltose. We use structure of glucose and galactose to form lactose. We'll see whether we can do the three. Let's start from glucose plus glucose. We're going to use the Hobart structure. We look like this. Then we have something like this. CH2, OH. We have OH, we have H, we have H here, we have OH, we have H, we have H, we have OH. Now, the maltose is formed by a glycosidic bond. Actually, all carbohydrates are formed by glycosidic bond. So the maltose is formed by 1,4 glycosidic bond. And it depends on what type of maltose that we want to form. Let's form a alpha maltose. Now to form an alpha maltose, the bond link will look like this. If the bond link looks like this is called alpha maltose bond. But if the bond link looks like this, this one over here is called the beta maltose link. So let's deal with the alpha maltose link. So we're going to be combining, let's use the alpha. Alpha maltose, remember, has the alpha maltose, remember, has the hydroxyl down on this place. But if it is the beta maltose, the hydroxyl is at the top of them. So we're using the alpha maltose. So we have this plus another sugar molecule. We have the OH, and then like this. So we have CH2, OH, we have OH, we have the H, we have the H, OH, H, OH, H. Remember we're using alpha. So we have H, we have OH. Now there will be a combination between these two. Now the combination of these two will form maltose. Now let's draw the structure of alpha maltose. We're going to have something like this. And then we have this. What you have on this side, we have on this side, we join it together. So we have this, and then this. So this is what we have. So if you have this type of bond, this is called a beta maltose. But if I want to change this beta maltose to, alpha maltose, if I want to change this alpha maltose to beta maltose, I will have to clean up this. I hope you are getting that. So let's do alpha maltose. Alpha maltose, let's do beta maltose. This one is called alpha maltose. Alpha, remember I showed you here. alpha. Then beta maltose is for this guy. So let's do beta maltose. Let's do it first before we change the name. So we have a structure like this, and then we have something that looks like this. Okay? Alright, so this one is called a beta maltose. Alright, I'll leave this one for you to do glucose and galactose. I'll leave that one for you. So help me to draw as an assignment the structure of lactose and the structure of glucose. Find a combination and draw any of those. Now let's talk about the hydrolysis of disaccharide. In the hydrolysis of disaccharide, we can use water and dilute HCl and dilute H2SO4, sulfuric acid. Now let's hydrolyze, let's start with maltose. Let's hydrolyze maltose. We have maltose, forward and backward reaction. We can add, let's use dilute HCl. And then we are going to form glucose plus glucose. Alright? So we can hydrolyze lactose using the same form. We're going to have glucose, lactose, galactose. So we are going to have sucrose now. If you hydrolyze these, you are going to still have glucose plus fructose. Now, let me give you an insight. The maltose itself, which is malt sugar, can be hydrolyzed by something, amylase. An enzyme known as amylase. This enzyme can hydrolyze this guy. There's another enzyme that can hydrolyze any of these. This one is lactase. Now, I will leave you to go and find the enzyme that can hydrolyze sucrose. Alright, having said that, we need to go to the polysaccharide. We need to go to the polysaccharide. Now, in the polysaccharide, let's write that down. I need you to pay attention to this. For the polysaccharide, we have glucose molecule, and then we have the cellulose and the rest of those. Now, for you to form a starch molecule, not glucose, a starch molecule, you need to combine a alpha 1,4 glycosidic bond. For you to form a cellulose, you need to combine a beta 1,4 glycosidic bond. Let me show you what I mean. What I mean by that is this. It is formed by glucose because polysaccharide itself is the condensation of many glucose molecule or glucose units. When we have more than outnumbered glucose molecule or glucose unit, we call that polysaccharide. Now look at the starch structure, the starch molecule structure, which is formed by alpha 1,4 glycosidic bond. Of course, you should know by now that glycosidic bond is what forms glucose. So, what forms starch? So let's go there. We have this. 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 So we have this. 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 So this bond is what forms the starch molecule. So we can have this in N. N means uncountable. You can have as much 5, 6 join in a link. And whenever this bond occurs, a molecule of water will be lost. Whenever a bond occurs, a molecule of water will be lost. Whenever a bond occurs, a molecule of water will be lost. Now let's form the cellulose structure. Now the cellulose structure is formed with the beta glucose bond. Let me write the bond. Beta over the beta 1,4 glycosidic bond. Okay, beta 1,4 glycosidic bond. So it will look like this. So if it is beta, something will go off like this, and then over here. So when you have stuff like this is a cellulose structure. Okay? This is a starch structure or molecule formula. Alright, like that. The next thing I'm going to do is to hydrolyze polysaccharide. So let's hydrolyze polysaccharide. That's the last one. In the hydrolysis of polysaccharide, just pay attention. Now, we're going to learn something. In the hydrolysis of polysaccharide, let's start with